Hello and welcome everyone to FAIRWork's 27th webinar, where today we will talk about conceptual modeling and how we used it in the project. So this collects two parts where we used conceptual modeling. So conceptual modeling, just a quick introduction that everyone is on the same page. They are diagrams with attached semantics. So semantically rich, like figures of houses and cars, or abstract constructs like rectangles and triangles, which have semantics. And we use them to use this visualization with the attached semantic in FAIRWork. And this was in the design and implementation configuration of our DIDSS, so our democratic AI-based decision support system, and then later also for supporting the explanations. But before I want to go into details, I want to set a bit of a context. So quick question. Do you see my screen, I assume? Okay. So
Yes.
thank you very much. So what we have here is the idea of FAIRWork itself. So and now I want to give a bit of context what we want to try and where we use conceptual modeling here. So the idea was, as already said, the creation, the design and implementation of the DIDSS. So meaning that we have human stakeholders, human actors, which have some needs or input for decision support, which we want to cover, in addition to organizational parameters like how many products must be produced, how many energy consumption, and so on. And we want to put them all together. And therefore, we need on the one side here, on the right side, visualized AI enrichment. So we need sophisticated algorithms and approaches to make this decision. So we have here different algorithms for different problems. Some assign, for example, the workers to a production line, others generate natural language for supporting. And so there are different AI algorithms like machine learning, rule-based systems, and so on, which we want to use. And this, we don't want to just implement one algorithm for one problem, but we want to have a flexible environment where we can easily add and adapt these AI algorithms. So therefore, we need these algorithms. Of course, we need some data. Therefore, we have here down the knowledge base where we save together in a coherent format the information about the organizational parts, like how many production lines we have, how many workers, and then we have also this personal data, and of course digital twins. So we have this kind of static fixed data that we apply, and we also have a variable data that is changing in knowledge base. At the heart lies the orchestrator, which then combines, different algorithms with together with the data from the knowledge base, and provides one instance of decision support for a specific decision scenario. And therefore, we implement some of the services and we combine them to the orchestration. The orchestration helps us to achieve this flexibility. And to do this, we need some kind of configuration. So we must identify which services belong together, with which data, and in which order they are called. And therefore, we have on the left-hand side the configuration, which is the main part of focus of what we'll talk about here, because here we have two parts, which is technical configuration, so an environment based on microservices where we can define these services and deploy them and run them. And what is the focus of this webinar is also procedures and methodologies that how we can identify the problem and design and create such an instance for this decision environment, so such a configuration, so that we then can use the services with the data together to support decisions in the real environment. And this is what I want to talk to you today. And I will present on my own. So I'm from Omilab, which is one partner who worked with modeling, and the other partner is also our project leader, which is BUC, which could not join because they have other work to do, but I will also present what they done. So we are, and Umlab and BUC were the main leads in this modeling for configuration. And if you want to have more information about FAIRWork itself, so the IDSS prototype, what are research contributions, we have additional webinars. This is kind of context that we where we want to apply it. Now, why we want to need this design methodology? Because for many organizations, it is a problem how to really introduce AI in a meaningful way. So there exists a lot of videos, research papers, frameworks, libraries that let you support the creation of AI services or implement AI decision support. But it's still a tricky problem how we can identify which AI solution is the best for a specific problem and how we can then introduce it and use it within the organization. This is where FAIRWork would introduce their design methodology, supporting from the identification of the scenario till prototype and configuration of this decision service. So because what we need is kind of two parts. We need to know about the AI algorithms that can apply. So what are there? Rule-based system, decision trees, machine learning, large language models, optimization algorithms, and so on. There are many different algorithms out there with their own benefits and drawbacks. And on the other hand, we have to understand the concrete problem. So what is belonging to the problem, what influences the problem really, and have a real understanding of the problem and not just some notion of what the problem could be. Because if you do not understand the concrete and the realistic problem, you cannot find solutions. And on the other hand, if you then have some decision support system, you need also acceptance by the users, meaning we have here people who are working with the system, which must trust the system. This provides feasible solutions, which is also a problem with AI because often it's not really understandable or easily understandable how the system comes to this conclusion. And of course, the solutions that are provided must adhere to the domain terminology of the people using it. This is further important because the people working with the service directly, decision makers, must accept this service and the result, but also the people influenced by it. So, for example, FAIRWork has a focus on production environments. So not only the people decide which products are produced on which production line and who is working where must work or must trust these results, but also the people assigned to the production. Because otherwise there is resentment against the system, against the decisions. And this is why we have applied this and designed this design procedure. This is what we used in the beginning of the project to design the whole DSS system and also the different decision services that we then created or were created by different partners. Of course, it's also that we support and apply in the context of the project. So we have here kind of three levels that we must consider. So the first one is on a high level, focusing on the concrete scenario and identifying on a high level what the goal is and who is involved and which parts of the companies are involved. Then we have on this high level, we cannot implement something directly, so we have to add more concrete information. This text here in blue, where we use processes. And then last, we have a technical alignment. So of course, here we're just on a conceptual level, understanding and designing, but in the end, we need some implementation or some running code or some running service who can help us. And now in a bit more detail, what is needed what do these different steps mean exactly? So the first is we want to have an understanding of people involved, come together and work creatively in a solution. So we use physical workshops that take place to further this co-creation. And the first part to support these workshops is that we have to prepare the workshop materials. So what we call here preparation, the main analysis is the people who start working together must have a rough idea of the problem and what can be done and what are the important aspects. This is just a rough idea that we can start quickly with the creative solution finding. So this is in before the workshop. Then we have workshops. So we also had them in FAIRWork directly. So where we traveled to our use case partners and had these workshops identified their problems that they want to tackle or discuss in the FAIRWork project. So here, knowledgeable people about AI, system architects, organizational management personnel, and informed persons from the project meet with the management and concrete workers from the use case sites and discuss the problems and create it with the subject tools here, paper figures, an understanding of the scenario, which we then captured with our scene to model tool, created automatically a digital representation, for example, and here seen in the red top side. And to capture it, process this, and share it. So this is kind of the first part. And afterwards, the people in the workshop and the project partners had an understanding of the scenarios on a high level, so they can communicate and identify important aspects, what we call here, what we call the domain vocabulary, so that we have what is important in our scenario, like we have some worker, we have an expert, we have a production plan, that we identify all these concepts that we need and what they mean in the context of this concrete use case partner. Because the role of a technician may differ between different companies, between different production lines. But of course, this is on a high level. And we need to make it more concrete so that we can implement it. Therefore, we used in FAIRWork business processes with the PPNN language. So we define first on a high level the landscape of the processes. For this, we used our Adonis tool, BOC's Adonis tool, where we identified the important processes, how they influence each other, how they are related to each other. Then the more important part that we can then start to think about concrete algorithms is we designed the decision processes. So it's important that you understand this model. It's just in the middle, the flow of the different tasks and decisions, what occur in which order. Then we have KPIs that are here captured. So this symbols at the top are the KPIs that we have defined, what we have to consider, what is important. And the bottom line, we have some data that is provided or generated by these steps. This is important that we then go from this high level of understanding scenario to concrete instances of which parameter do we have, what is the goal KPIs that we have to fulfill, which information can be provided in which way. And then after the modeling, we have, of course, a technical alignment where we use, again, further models from other teams or architecture models together with real implementation. So what we have here in this picture is top, what we've already discussed with design thinking, the process model, the models of understanding. On the bottom, what we also need is, of course, knowledge about the AI solutions, the algorithms that we have available or exist, how we can then implement them and use them. This is on one hand, knowledge about the algorithms that we have and already which AI services we already have implemented in our DITSS and how we can configure and reuse them. And in the middle, we map them together. So with the input from our understanding of the concrete problem, we then create the decision models and instantiate our services that can help us with this decision problem. And then at the middle and at the end of this middle step, we then have our service that can have an interface, and user interface, so people can interact with it. And this is kind of in another structure. What we have in this design procedure is where we have it also in different layers that must be run through. So the identification is mostly what we have talked about now in this design procedure. Different models, physical workshops, and modeling methods. And just to be sure that these BPMN models that we had are also run through multiple circles. So this is not just that we then create one workshop, then have one model created, then we can start. So this is also a cycle of evaluating and refining the understanding of the scenario till we have a version that can be used and understood by everyone. But after then, we now have mapped identified some AI solutions that we then have to implement or identify or specify how we can use them. So on a conceptual level, this is the specification layer, meaning that we, for example, if we decided for rules, we define the different rules in a still generic way. What must be decided? For neural networks, we decide here which parameters are used input for the neural network, how the output should look like, maybe which type of neural network should be promising here, but this is still independent of a concrete implementation. And then we can use this conceptual level representation for in the configuration. So we then translate it in something that's machine understandable rules. For example, we translate in a way that the rule engine understands them, the neural network, the architecture, the input variables, the data, we translate them in a way that the neural network environment can understand them, like, for example, this Python environments, which you can train a large library. And then we have here a machine understandable configuration of this decision, the trained network, the rules, and so on. And then we load them into a framework, the microservice framework. For example, we use BUC's Olive environment. We can then deploy services with REST interfaces that can then be called and integrated in the user interface through the orchestrator. So what we have is summary, identify the problems with supported with these models, then we specify the information further on a still independent level. We make it in a machine understandable configuration, then we deploy it. So we have a quick overview how something like the models can look like that we use before we go into details, examples what we have done in FAIRWork. So the one scenario was that we make a worker allocation. So which worker can be allocated to which production line under consideration of the worker's well-being. So the medical condition, the availability, and also the physical resilience. So how fit they are, how much stress they have, so what can they work, because different production line, we have different products built with different physical strains. For example, some produced products are very heavy that must be carried. So this is a very tiring task, or if you just have this light. Then we need different ways to implement them, and how we work with this, identify this in a way is, for example, we have here a scenario model created within the model after workshop, where we have in the middle here the definition where they come from on what is needed for this worker allocation, where we have this different kind of components and people available and assigned to this production. So it is not important that we know this in detail, but just this is kind of an example how this look like. We have this semantic figures, and they have now semantic assigned to them. What this all means, for example, we have this is a someone responsible for the actors. We have UTE head. We have the workers on the production line and the people who carry them, and the different products that they produce. Then we have translated this over multiple iterations to a decision process, which shows the different tasks and assigns the KPI. So we have talked about it in a more detail, and then we use this information within the project. So one example would be for this work allocation, then defined the main decisions and parameters that we have defined in BPMN, and then we translated them in something that is more machine usable or concrete for a rule-based system. So we decided for this one experiment to use rule-based systems. So we used the DMN notation. This is another modeling method where we define the decision structure and the decision logic. So the structure, for example, we identified that we have omission criteria. So if one of these is not true, then the worker is not able to work at the production line, and this is missed right away. And the other ones are more for ordering them. And then we identify these concrete decisions in a table, which is still independent from a concrete decision engine, but understandable for people. Here, we then made kind of a shortcut through the configuration. Then we enhanced this DMN model with technical information. And because we have now a model and not just this diagram, so the semantic behind them and processing capabilities, we can create everything out of this model together with this decision table that we need to instantiate a rule-based decision service in Olive. So this is what we could do. We then export this, create this create this configuration, imported this into Olive control, and this instantiated, deployed it, and made a REST endpoint, which was then connected through another configuration in the orchestrator and to the user interface. This is kind of for the rule-based approach. We also have other kinds of services that we applied, for example, LLM, where the models are not used directly as defining the decision logic, but providing context to this decision making. So the case here was that technicians must fix problems in the production lines, in the machines, and maybe they do not have experience with all the machines. So this decision service was created, which provides information in natural language to the technician, describing what is important, the steps that the person must proceed to fix this machine. And where here have what is input is one, the documents, wiki, past tickets, so information is gathered about the machine. And now we need a way that we let the LML-based service know what exactly it needs. So therefore, we have also models here. In this example with R2AT, so the structure of the information system, which machines belong together, what are their specifications, and we need this information provided to the LLM that it just not tells us everything, something or hallucinates, because we need concrete information, because otherwise we can destroy the machines, which is very bad in production line. I think you can imagine. And what is happening is if the technician asks the service about a specific machine or about help in a specific ticket, it gets us some similarity in this documents, wikis, and the models, transforms it in internal vector databases that it can search it then and provide it with the swag information in the range, enrich the prompts, and then generate an understandable natural language answer to this persons. So we have here different ways of using models to support decision services. One is that we really encode the decision knowledge. The other is that we provide context information. This was for the design and the configuration. And in the other direction, we supported explainability. So we use this graphic representation, which is easy comprehensible for humans, to support this explanations of the decisions which were made for the humans. It's because I see now that I'm The time is flying by. I will make this a bit quicker. So we have here two different kinds based on the input that we gather. If we have more structured information, we can reuse the existing models that we created during the design time. So what I explained before in this procedure, we have created these models and we can reuse them by mapping the result of the decision systems. For example, we have now the workers with these parameters assigned to the production line, or how the decisions map out in this concrete scenario. We can now, and because we don't have just a picture, but a model, we can map this to the beta model or to the domain vocabulary that we used to enhance these models, show the parameters, influence the notation of the models. We can easily see what is the decision output or influence from the starting point to what we have then after the decision is made in a closed environment. Then we can use these pictures in addition to other explanation parts to show it to the user to support the interpretation of the results. And of course, as we used also textual descriptions, for example, with the machine maintenance use case, we can also use this textual description to create models that fitting to this text. So we have here an OR input from either we can provide some information, documentation, documents about machines on how they can be facilitated or repaired, or we can use the direct input from the decision service in the textual description, put it as input for our service, addition with our meta model description, so the meaning of the modeling method encoded in natural language. So we have to add this description to this modeling method and use as input, and then we can put it together. And also large language models can then create a model and a diagrammatic model. So with a visual encoded representation of semantics, send this to the modeling tool, and then it again create some visualization which can be used together with the text description to facilitate the understanding of users. So, and with that, I want to say thank you for your attention. Of course, if you have any questions, you can contact me, Christian Muck from OMILAB. You can contact people from OMILAB directly, or our colleagues from BSc who were not able to join today, but also provided to the content. And before we end, I just want to ask if there are any questions regarding the content. I think we explained more detail. Then thank you very much, everyone. If there are no questions, then thank you for joining this webinar, and hopefully see you soon. Bye.